In an Aerospike database, the data model is determined through the use of the system, rather than requiring a schema like a traditional relational database. First, let's spend a moment on physical storage. Data can be stored on NVMe flash, DRAM, or Intel Optane persistent memory. This is referred to as the storage engine. The data model begins with a namespace. This is the top-level data container that stores records and contains policies that define things like the storage engine used, the way data is managed, and more. As mentioned, records are stored within the namespace and can optionally be grouped into sets. We'll come back to this in a moment. A database can have multiple namespaces, each with its own policies and storage engine. This allows for use of the storage medium that works best for the data being stored. For example, I might configure small, frequently accessed namespaces in DRAM, while putting larger namespaces in less expensive flash. Inside the namespace, records may be grouped into optional logical containers called sets. These sets inherit the policies defined in the namespace, but you can define additional policies or apply operations like secondary indexes or scan operations. Multiple sets can exist within a namespace, and records that don't belong to a user-defined set belong directly to the namespace in the null set. It is highly recommended you define a set. Records are made up of three components. The key is the unique, user-defined identifier for the record. Metadata stores information about the record. Here you'll find a generation counter, time to live value, and the last update time. Finally, bins are where the data lives. A single record can store multiple bins and data types within them. Data types are not defined by the bin, rather the type is defined by the value within the bin. This provides flexibility in the data model. All these pieces together help to define the Aerospike schemaless data model.